Hi everyone, welcome to this week's Half Paper Friday. It's a calculator paper, so get your calculator out, get your paper out, and let's improve your understanding to get a better grade in maths. So question 1, 4y minus y, add 2y. We follow the order of operations, and that teaches us that we need to subtract before we add if the subtraction is before the addition. So we've got 4y minus y is 3y, add 2y gives me 5y. Find all the factors of 40. So some people miss some factors because your listing wasn't very efficient. 1 and itself, double it, half it, double it, half it, double it, half it. List all 8 factors on the line. They don't need to be in order, you just need to make sure that you write all of them to get both of the marks. Question 3. Casey throws a fair coin. On the probability scale, mark with across the probability will land on tails. So there's 2 outcomes on a fair coin. You've got heads or tails. Tails is 1 of 2 of them, so that's a half. And you'll notice my cross is on the line. Autumn throws an ordinary 6-sided dice. On the probability scale, mark with across the probability she will throw a 7. If you list the outcomes possible on a 6-sided dice, we'll notice that there's no 7s, so that probability is 0. There are 3 yellow sweets and 1 blue sweet in a bag. Dennis takes a sweet from the bag. On the probability scale, mark with a cross, the probability will take a blue sweet. So there's 1 blue sweet out of 4 in total. And what we need to do is understand where 1/4 would be on this probability scale. So if 0 is 0 quarters and 1 is 4 quarters, a half is 2 quarters, 1/4 is halfway between 0 and a half. And that's done for 3 marks. Question 4, reflect triangle P in the y-axis. So the reflected image needs to be 2 units away from the y-axis, and it needs to be a reflected image, not a translated image. So this is a reflected image. I'm going to use a ruler to join up the vertices. For my reflected image. Reflect triangle P in the... we've just done that. Draw an enlargement of shape Q, scale factor 3. So the word enlargement means change the size of, not necessarily meaning get bigger. But in this case, because it's a scale factor of positive 3, it will be increasing in size by 3. So I'm going to start my enlarged image at this same position as my original image, and I'm going to increase the length of the first side by 3. So that length of this side is 4, and 4 times by 3 is 12, which takes us over here. From this position, the original image goes up by 2. So that's going to be 2 times 3, which means I'm going to go up by 6. Then this is the one that will challenge most people. This distance needs increasing by 3, which takes us to that final position, and then we need to use a ruler to join up the vertices. And there is our enlarged shape. And we can check that our answer's correct by just checking this one, that's 3 units. And what we should find is that this is 9 units. And that is enlarged. Question 5. A pile of sand has a weight of 65 kilograms. Some of the sand is put into a small sack and the rest is put into a large sack. The sand in the large sack weighs 15 kilograms more than the sand in the small sack. What is the weight of the sand in the small sack? So I'm going to form expressions for the sand in the small sack. I'm going to call it x, which means the sand in the large sack is x plus 15. We know that the total is 65 kilograms, so I'm going to form an equation. 65 equals x add 15. I'm going to solve that equation to find the value of x, which gives me the weight of the sand in the small sack. I solve equations using inverse operations. The opposite of add 15 is minus 15. And then the opposite of times 2 is divide 2. To get 25 equals x. And that's going to give me values of 25 and 40, which if I check adds to 65. So I know that it's going to be 25 kilograms in the small sack. Question 6. An internet bookshop uses this advert. Every third customer gets a mystery prize and every 20th customer gets free postage and packaging. So that's important. We've got every third and every 20th. On Tuesday, the internet bookshop had 150 customers. Part A is how many of the 150 customers get a mystery prize. So your mystery prize is the every third customer. So we know that that is how many threes are in 150. That is 50. Part B is how many of the 150 customers got free postage and packaging. So if we list our multiples of 20 this time, we know a 20th, 40th, 60th, 80th, 100th, 120th and 140th customer will get free postage and packaging. So that gives me 7 customers. If you did the same method as the first part and did 150 divided by 20, you would have got 7.5. That isn't the answer because we can't have half of a customer. 8 would be wrong because that would require 160 customers. We only had 150. Part C is how many of the 150 customers got both a mystery prize and free postage and packaging. So in this question we need to find all of the common multiples of 3 and 20. So if we focus on the multiples of 20, 60 is our first multiple of 3. So now our 60th customer gets both. And our 120th customer is our next multiple of 3 and of 20. And then we have no more customers that are both multiples of 3 or 20. So that gives us our 60th customer, and our 120th customer gets both prizes. That is 2. Question 7. Show that 7.5 minus 4 2/3 equals 2 3/6. So we change each of these mixed numbers into an improper fraction by multiplying 7 by 2 and adding 1 to get our numerator of 15. And then we do 4 times by 3, add 2, which gives me our new numerator of 14. So we've got 15 halves and 14 thirds. To add and subtract fractions, we need a common denominator. The lowest common multiple of 2 and 3 is 6. So we'll multiply this fraction by 3 over 3 to get 45/6, and this fraction by 2 over 2 to get 28/6. I use a calculator to subtract 28 from 45. 45 take away 28 is 17. So that leaves me with 17/6. If I list my multiples of 6, I can see that there's 2. And we got to 12, we're at 17. 17 take away 12 leaves me with 5/6 left over. And that's shown that the answer is 2 5/6. Question 8. The diagram shows lines of a netball court, and the court is made up of 3 rectangles and 2 semicircles. All corners are right angles, and Jacob's painting the lines for the netball court on the floor of the school sports hall. Work out the total length of lines of the netball court and give your answer to the nearest metre. So it's quite a big question for 4 marks. We use the fact that opposite sides of rectangles are equal in length. So we've got a full length at the top of 30.5 metres. So we know that the bottom length is 30.5 metres as well. We know we've got a height of the height of the rectangle is 15.25. So I've got 4 of those lengths in total. And then the last part that we need to consider is the length of 2 of these semicircles. So when we put 2 semicircles together, we'll get a circle. I check my formula sheet for the circumference formula, because circumference is the length of a circle that we call the circumference or the perimeter. And that's the formula we need to use, not the area. So if we've got a radius of 4.9 metres, we've got a diameter of 2 times by 4.9, which gives me 9.8 metres. So the circumference then is pi times by 9.8, that I'm going to keep as 9.8 pi. I'm going to add up these lengths to get the total length. 9.8 pi add. I've got 2 lengths of 30.5 and 4 lengths of 15.25. I'm going to type that in on my calculator. 9.8 pi, add 2 30.5s, add 4 15.25s. That gives me a total length of 152.787608, and then we need to round it to the nearest metre. That 7 tells me to round up 153 metres for 4 marks. Question 9 on the grid, draw the graph of y equals 3x minus 2 for values of x from -1 to 3. On a paper 2 or 3, I'd recommend that you use the table function on the calculator by pressing home, right, and then inputting twice into your tools. Firstly the table range, and then the defining the function. But this is also a paper 1 skill, and because you can't see my calculator screen, I'm just going to model the solution of how I'd deal with it if it was a non-calculator paper. So I'm going to use the values given to me of -1, 0, 1 and 2 and 3. And I'm going to fill in my own table of values by substituting the value of x into the equation. Y equals 3 3's minus 2 gives me the value of y when x equals 3. That is 7. Y equals 3 lots of 2 minus 2 gives me the next value of 6 minus 2, which is 4. Y equals 3 1's minus 2 gives me 1. And then I can see that that is going down in 3, so I'm going to just subtract 3 to get the last 2. I'm going to plot the graph using the coordinates -1, -5. Zero, -2, 1 1, 2 4 and 3 7. And then don't forget to join it up with your ruler to plot the line. And that is the line of y equals 3x minus 2. Question 10, for 4 marks, we need to form an inequality. We've got Annalise is 5 years older than Tia, and Lexi is twice as old as Annalise. The total of their ages is less than 30. What is Lexi's greatest possible age? Give your answer as a whole number of years. You must show all of your work in. So we've got Annalise is 5 years older than Tia. Let's call Tia's age x, so that we can call Annalise's age x add 5. Then we've got Lexi, who's twice as old as Annalise. So that is 2 lots of x plus 5. Because Annalise, we've already given an expression as x plus 5. And that's the same as 2x plus 10. What is Lex's greatest possible age? So we know the total, that means add, is less than 30. So I'm going to add up these ages and write less than 30. And then I'm going to collect like terms and solve the inequality. So I've got 4x add 15 is less than 30. And I'm going to solve this inequality using inverse operations. The opposite of add 15 is minus 15. The opposite of times 4 is divide 4. Giving me x is less than 3.75. The age then that I'm going to use, the greatest possible age for Tia, would be 3. Because 3 is the greatest number that is less than 3.75, greatest integer. So I'm going to substitute the value of 3 into Lex's age. That gives me 2 3's add 10, which equals 6 add 10, which is 16. It's worth checking for 4 marks that this works. So if we know that the value of x, the greatest value of x for a whole number is 3, we could substitute the values in to give Tia an age of 3, Annalise an age of 8, and we know that Lex's age was 16, and if you add up those values, you get 27, which is less than 30, so we know we've done it right. Question 11 is a pie chart. Underneath the column where it says bed, I'm going to write the number 360 divided by, and I'm going to find the total of 15, 10, 20 and 27. So 15 add 10, add 20, add 27 is 72. And that gives me an angle for each bed being 5 degrees. We're going to multiply each frequency by 5 to find the total angle for each sector. That gives me 75 degrees, 50 degrees, 100 degrees, and 135 degrees. Now I'm going to try my best to plot this pie chart using this ruler. It's easier with a protractor. The ruler kind of is a protractor, but I'm going to have to try my best, and I'm going to need to use my knowledge of what angle that we're at. So we're at 15 there, so I need to go to 50. So I'm going to have to be 15 and 35, so it's going to be 50. That's going to be accurate. You'd be using your own protractor, so yours would be easier to calculate to get the correct angle, but this will work. Just don't look at the angle that I'm drawing because I'm using an iPad protractor. So that's the thrush, and I'm going to just label on there 50 degrees, and then I need 100, so I'm at 50, so I'm going to be looking at 100 degrees. I know that's going to be, it's going to be difficult. Let's do it from the top one. So 100, that's at 90. It's probably better to fast forward this bit, everyone, if you're watching the video, while I just work out what to subtract from with the numbers that this one's giving me. So I need to go to 20 degrees there. That should be perfect. And that's where I'm going to write Stalin. And then that one is going to be Sparrow. And that is plotted. Good job. Last two questions. Here are the first 4 terms of an arithmetic sequence: 3, 10, 17 and 24. Arithmetic is another name for a linear sequence, and that means the first difference of the terms in the sequence is the same. So 10 take away 3 is 7, 17 take away 10 is 7, 24 take away 17 is 7. That means this sequence is linked to the 7 times tables. So we start with 7n. Compare them to the 7 times tables. 7 times 1, 7 times 2, 7 times 3, 7 times 4. From the 7 times tables, to get to our sequence, we need to subtract 4 each time. So our nth term is 7n minus 4. Is 150 a term in this sequence? You must explain how you got to your answer. So I'm going to form an equation. 7n minus 4 equals 150. When I solve this equation, if the value of n is an integer, that means whole number, then it means it is in the sequence. That's 154. The opposite of times 7 is divide 7. N equals 22. So you must explain how you got to your answer. It is a yes. 150 is the 22nd term. Final question. Each length of the side of square B is twice the length of the side of square A. Jensen says that this means the area of square B is twice the area of square A. Is Jensen right? Justify your answer. So let's just quickly sketch two squares. And we could give square A any side length. So I'm just going to use the number 1. And if we're looking at B being twice the length, then that has to then be 2 for square B. So if we calculate the area of square A, that would be 1 times 1 base times height, or 1 squared, which is 1. And if we work out the area of square B, that would be 2 times 2, or 2 squared, which is 4. Then let's have a look at the question. Jensen thinks it means the area would be twice of the area of square A being twice of square B. I can see that it's 4 times bigger. So is Jensen right? Justify your answer. No. The area of square B is 4 times larger than A. And that brings us to the end of this week's Half Paper Friday. Well done for getting on with it and watching it and improving your understanding. See you in the next one. Bye everyone.